at the Czech Technical University, Czech Institute of Robotics, Informatics, Cybernetics. Those who speak Czech or Slovak may imagine how the institute would have its name without the cybernetics at the end, and have fun. For the others, I will not translate. Before we start, I try to make sure that you all know that this is a non-smoking flight. Please fasten your seatbelts and be ready to have some fun, because that's the main reason why we have summed up here today. We have also a few people online. I'm not aware about how many of people we have on the Zoom online, but there is a conference ready there. I know that Pavel Kordík, for example, is already online. Yesterday he was playing volleyball, and when he was smashing, he stepped back on his leg so bad, so he's now lying in his bed, taking some pills to stop the pain. So he apologizes, he's not going to be here. I'm just, socializing a bit before everyone sits down. Perhaps if someone wants to sing a song, we can sing a song before we start. And as you see, we have Roman Seikot here taking photos, so I'm very keen on having him because he's originally an art photographer, so what he does is real art. And the next thing I would like you to notice is the robotic bar on the entry side, which sometimes gets powered up and serves beer in a robotic way. So we will be inviting you for different openings. However, we're a bit over time now, so I will welcome Karel Charvat to start today's event in his own way. Karel, welcome in our premises and have the Geo AI event started.
Thank you, David. Thank you to all who came, and I think we can start shortly. Can you put my presentation? I am happy to be here on this institute, which is one from the biggest and most important center in Czech Republic for robotics and AI, and we work together some months to prepare these events. It is not conference, it is really something putting people together and to start to working together about Geo AI. I think that on the beginning there were two projects which started between people from the group of Plan for All and Czech Technical University, and it was Polyrural Plus and Alliance. We start to work on different AI solution, but we are cooperating also with other. And our goal is to support building of a European Geo AI solution. I will later explain a little more, but it is necessary to put together different experts from different domain, not only programmers, not only technicians, but also potential user community, to be possible to suggest something which could be useful and which could be deployed in Europe. So I think that I will speak later much more about Geo AI, but I think that Geo AI is something what is in reality on the beginning to become something for more people, because till now it was mainly for the limited group of experts, and we would like to open this for large communities. So this is something what we would like to start new, and because it will be not about me, it will be about you, because most of you are programmers, technicians and other. So there will be chance to sit together in different teams thinking what we can do. And of course it is only start, yes. During these 2 days we will be not able to solve anything, but we can generate ideas, we can link some connection, because I think that for the future it's necessary a little to support bottom-up approach. Yes, there is number of projects which are supporting this event. There are people representing many projects, and if we will be able to connect people from this number of the project, and if we will be able to work together, I think that we can do also something. You will see some presentation from some projects which are already working, and then will be possible to speak and discuss about the future. So, David, maybe if this organization thinks will you also here you can see the organization who cooperate on the preparation. Yes, David, maybe that this you can.
Okay, how much time do I have?
Short time.
Short time. So this will be a short, I'm sorry. This time it will be short. Next time I'll be longer. So welcome at the venue. We have some links you may use. We have 4 gravity centers. This is the first one for today. Tomorrow we will all meet at the other one. You know, walking directly through this robotic center, you will find the A101 room where the jackdaw and the food will be served. And next to it is a 102 small room where the policymakers should gather, or groups up to 12 people. And then after this session here, we'll all move to a 303, apparently in 3rd floor next door, where we'll open the discussions in individual groups. All the rooms are card controlled, so don't be fooled that you cannot access it by yourself. You need a guidance that someone lets you in. There are 4 key people. Barbara is now working at the registration. Eva, we have Eva again at the registration. Teresa, we have Teresa over there. And you have me. So this is the yellow badge that you should look for in any case of your trouble. We have all hand meetings today. Following the keynotes, we have a very good catering company which was able to prepare for us even a dinner, so we don't have to go out for dinner. We can stay in the A303 or A101. The tomorrow's meetings will start next door, entry A in 101, 303, and then there are a few useful links that I have not prepared, so it's not there. That's it for the organization. Every room, every floor has their own bathrooms. How many smokers do we have? Are there any smokers? No smoking. So it is really a non-smoking flight. So for the smokers, you need to contact me so that I would let you out and also back in. I will not smoke with you, I promise. Sometimes. Karel?
Thank you. And now our first keynote will be Philip. He's General Secretary of ADRA. I am working with him mainly about some strategy for AI and robotics in agriculture. And Philip would like to tell us a few words for ADRA. Philip is not with us here. He will speak remotely from. I would like to ask the colleagues to switch. And Philip, please, if you can start with your presentation.
Thank you very much for the introduction, Carol. Hopefully you can hear me okay.
We hear you well, thanks.
Excellent. So thank you very much for inviting me to speak today. I am going to deliver a short presentation on ADRA, how we're trying to create the AI data and robotics ecosystem. I'll speak a little bit about the agri-food group that Carol mentions and some of the ambitions there. So in the first instance, I will try and present my presentation. And hopefully in a second you will see that come up. So is that visible to everybody?
Ooh.
Interesting.
They are trying to solve things.
I am screen sharing.
Yes, now it's okay.
Oh, excellent. Fantastic. The one thing I just need to do though is to, oh, let's just keep going. So, why is this not moving forward? Ah, I'm running into a technical issue. My Microsoft PowerPoint has stopped responding, so I just need a few seconds to try and get it to work again. Okay, I'm going to try one more time. Apologies for this. So, sorry about that. What I'm going to do today is run through and set the context a little bit for the challenge that we're facing in Europe in terms of AI data and robotics technologies, but I think in particular with an emphasis on AI and how we are lagging behind other parts of the world, what we feel should be the kind of response and the journey that we need to go on to start to compete, and how within Agile we're thinking about the kind of strategic elements and we're working with the Commission. I am unable to move this forward. It keeps crashing. Right. What I'm going to do instead is when I share the presentation, I'm not going to go into full screen mode because it seems to crash on full screen mode. Right. So, sorry. So as I said, we're kind of standing on the crossroads of technology leadership globally here, and there needs to be a new response. The ongoing digital transformation in which AI is playing a key role offers a huge opportunity for Europe, and it's really Europe has to grasp that opportunities. As I mentioned, on a kind of geographic level, Europe is lagging. We do not produce the AI technologies. We don't develop the AI technologies, and we don't deploy the AI technologies quickly enough in order to be able to compete. There is a recognition, I think, at European level now. I'm sure you've all heard of the Draghi report and the Heiter report, but there's a real need to respond and reorganize, because the productivity gains that we're going to get from deploying this technology are massive. And the regions of the world that manage to do first will have the advantage. Importantly here, though, these technologies also offer a massive also opportunity to respond to some of the sustainable development goals and to respond to the kind of societal challenges that we're facing. So as we're trying to kind of work out the potential uses and misuses of AI and large language models, we're also seeing a kind of trend developing, and this trend is in relation to the way that we see AI gradually being embodied in robots. So the two examples here are on the right hand side, you'll see here a robot being trained with OpenAI, technology, and on the left, this is the kind of robo gym from NVIDIA, and both of these examples show that these are technologies that are being taken very seriously by, on the one hand, a software company, on the other hand, microprocessing manufacturer. So how should we be looking to kind of solve the problem in Europe? And it's really important to start with the premise that we have some exceptional areas of strength in Europe. Our manufacturing base, our kind of research institutes, our skill base and talents that we produce here are all points of strength. And I think we've also seen very positive changes in Europe over the past few years that have helped to make our ecosystems, our research and development ecosystems, our innovation ecosystems more kind of coherent and come together. Our funding, the funding in Europe, the funding gap has been bridged. And there are, again, some emerging areas of excellence in Europe that we really need to work into. So the way that we look at leveraging these technologies and these developments is in a public-private partnership with the European Commission. We work most closely with the European AI Office, and this partnership sets out to invest 2.6 billion euros over the term of the framework program, Horizon Europe, into these technologies to achieve technology sovereignty, boost industry, develop research, and importantly also deliver on social impact. So Agile work is the kind of bridge between the private side, which is representative of industry of different shapes and sizes, the research community, RTOs, academia, and also the kind of public interest organizations. And we work with the Commission to look at, how do we deliver sovereign AI technologies? Where does the investment need to go? What are the elements of infrastructure and ecosystem that need to be developed? And on the other hand, so how are these end user industries better able to uptake the technologies and apply the technologies in their particular sectors? So the way we do this is we break the problem down across sectors and across areas of interest. We have vertical interests that focus on topics such as energy and agri-food and manufacturing, and we have horizontal interests that touch on standardization or policy, etc. And this is all in an effort to create an integrated network, community of excellence that acts as the single point of contact for AI data and robotics in Europe and the European Commission, an integrated network. We stimulate some of those multi-stakeholder collaborations, and I think importantly ensure that the private sector interest and private sector research is aligned with what the public sector is focusing, because that's one of the ways that Europe is able to develop the scale that's necessary to compete globally. So we've borrowed here the kind of line act to accelerate idea from the Hydro report, because I think there is a need to think again about the challenges that we're facing. And within ADRA, we have these 5 strategic pillars that we're looking at focusing on, and we look at the way that we kind of organize within the organization, but we also think that they are the points that we should be looking to progress in the ecosystem. So the first is our strategic research, innovation, and deployment agenda. So this is the vision for Europe. What does Europe want to be really good at? Because we have to choose. We have to be able to identify a handful of opportunities and really work into them in order to be competitive. Focus on high impact pilots for industry. So AI and robotics integration, software and hardware convergence, because we think that being able to capture the whole technology stack is, again, one strategic point that Europe needs to develop. We think there needs to be a stronger focus on challenge-based approach, on stage gating. And I think it goes back to the point that Carol was making about how do you stimulate some of these bottom-up activities, because I think that's really, really critical. You know, how do you get more a more evidence-based, productive technological developments happening from bottom up? Then finally, how do we support the European Commission in its in the development of harmonized standards? But again, importantly, how do we make sure that on a global level, these standards are also being taken seriously? Because what we want to avoid is just a regional approach to the way that we're doing standards. And finally, it's about creating confidence across member states' policies and ecosystems, so that the funding, the policy approaches can gradually become more coherent across European and member states levels. So two things that I just want to focus on a little bit from that side is this is the strategic research and deployment agenda. I'd recommend that you will all go and have a look at that to learn a little bit more about the priorities that we feel are going to be important over the next few years. And this document also impacts on the funding for under the Horizon Europe work programs. We also think that something that is really, really critical here is how we look to bring this ecosystem to life, the European AI ecosystem of trust, which is supported by the AI Act, and European ecosystem of AI excellence, so the innovation excellence, and how we can work together with the office, the member states, and all the individual parts of the ecosystem to support the discovery of new technologies and also the scaling of these technologies. So something I did just want to focus on here, and it's relevant because of the what I'm going to say in a minute on the agri-food topic group. But what we want to do is we want to be a thought leader in the way that we consider some of these issues. So something again that might be worthwhile having a look at is this policy paper and technology roadmap for Gen AI and robotics in Europe. And it's really about, you know, these papers get used by the European Commission to, you know, enrich their understanding of what the opportunity is for Europe. And I think, you know, generative AI is one example where we could be, we need to be trying to capture the value. And this brings me on to the agri-food topic group. So Carol, along with Andre and Giovanni, drive activities here. And the main purpose of this group, as it is with the other groups, is to try and create a coordinated sense across the whole of the European Commission of AI data and robotics initiatives. How do we bring that together? How do we make sure that the ecosystem starts to work in a way that is interdependent, and then it really feeds into kind of starts to develop a kind of integrated sense. There's also this fundamental point here about kind of identifying the research development and innovation priorities for Europe in agri-food. So again, one of the concrete steps that we would like to be developing over the next few weeks, months, and probably the rest of the year is looking at a policy paper and technology roadmap that sets out some of these ideas. And also, again, it's about defragmenting the ecosystem and working with other parts of the European Commission, working with other directorate generals to bring together their areas of funding, so that we can have more concentrated levels of funding, but also a better understanding of what needs to be supported. So I'm just going to finish here with the kind of ADRA team, and you know, our board of directors kind of crosses the whole of the European Union. We have representatives from a number of member states from associated countries, and they're all very well embedded within each one of those individual ecosystems. And we're looking to work much more closely with member states to start to develop again that kind of coherent sense of programs that will concentrate the funding and the efforts. And this is our small but growing secretariat at ADRA as well. So in summary, it's about building Europe's innovation ecosystem and integrating AI data and robotics technologies, because it's not just about developing those sovereign technologies, but it's also about identifying the application areas. We want to drive collaboration. We want to make sure that research and industry has a better understanding of what each side is doing. We want to advance strategic initiatives, so things like generative AI for robotics, but also what does the future hold for Europe? What does the future hold in terms of hybrid forms of AI, neurosymbolic, and where are the things that we need to be focusing on to ensure that we're not left behind? And finally, it's about empowering impact. So we're making sure that those conversations that happen on the level of policy of funding get fed into the thinking around, at the level of member state policymakers, at the level of the European Commission policymakers. And just finally, a call to action to join. So if you have an interest, all of our topic groups are completely open to join. Then we kind of create membership levels of benefit within the association. But we would encourage all of you to join. It's very simple. You just go onto our website, you find the topic groups, and you just add yourself to the mailing list. And then once we have our upcoming meetings, you'll be invited to them. So just to finish, thank you very much for inviting me. Sorry about the technical element of this, but hopefully that was useful. And I don't know if there's time for questions or that's it. That's fine. Just let me know.
Thank you, Philip, for your presentation. I think that applause is necessary. I would like to mention that I'm happy that you are with us here, because our goal is to put people together. Here we are more on the side of the technology community, and I think that ADRA could be in the future good bridge between us as the community of scientists, developers, and other, and public sector, mainly European Commission, because we need to work and we need to have strong voice to show that we have some idea and to be able to make some suggestion, and ADRA could be one from the important organization which can help us. I would like to mention that two from organization who are organizing this Circ and Plan for All are already members of ADRA, so we are involved, and I hope that in future more Czech organization or other will also join. I would like also stress one thing. Philip, you mentioned importance of standardization. I am happy that we have here today representative of OGC, because mainly in the area of Geo AI, OGC as international standardization organization can play important role. So I think that we are trying really to work not only on the level of technical people, but also to be able to influence in the future the policies, but also the standardization. So is there some question to Philip? If not, I would like one more time to thank you. And I hope that you will stay with us for the rest of this opening session. And the next will be again for me. So if you can. Okay. As you can see, I am probably if not oldest, but one from the oldest persons in the room. I see here some 3, maybe 4 faces who can remember also something what about I will speak in my presentation. The rest of you are usually very young, so maybe that we can look a little to the end. AI, and also I will explain that Geo AI are not new. Yes, it is started already. The first idea started already many years ago. I will speak later. But what is new? There are 2 things that the current computer power and also development in large language models completely change the situation with AI. Yes, so AI started many years ago, but now I think in last 3 years they completely start to change environment about AI, but also Geo AI. The development of artificial intelligence started already in 80s. I have to say that there were few people who in this time bring me to AI. Some are already not here, like Ivan Havel or Docent Hořeš, but some people are also till now working in this room, like Professor Mařík or Professor Hlaváč, with whom I work from the beginning. Maybe that it could be surprised, but already in 80s we had annual conference in Czech about artificial intelligence. So, and it was organized by Professor Mařík, who is, I think, here from the CIRC. So it started already in this time, but of course most of work was done mainly on experimental stage. Around 86, I developed my first backpropagation algorithm, and I started to test this at the beginning. Probably you cannot imagine this, but the computer had 32 kilobytes of RAM and 5 megabytes of disk. When I move on a computer as a 1040 with 100 megabyte of disk, and I don't know if there were 1 megabyte of RAM, it was something that I didn't believe that it is possible to use this. Yes, so this was the time of the beginning, but already in this time people start to play with mainly backpropagation, Kohonen networks, and these things, and there start, of course, experimentation. It started already long time with Geo AI, we can say, but it was also the work for expert, because my first, what I mentioned this backpropagation algorithm, I used this for classification of satellite images in this time. Yes, it was only 3 layers network, but I start to work with this, and we made experiment. And I know that there were many people, because in this time was not possible to go on the GitHub and download some software and start tested some software, but you had to done any of these algorithms own self. So I work mainly in this time with Fortran, and I think that this was a very effective language, because it helped to do very effective code that it was able to run on such lower computers like was. Yes, so because you have to optimize all, and the Fortran was good language for this. But of course, non-expert was not able to use AI or Geo AI, because it was only possible to do something and then to people show the result. I think that one from the big AI events which large community start to recognize that there exists something very strong was then in 1997 the Deep Blue won against Garry Kasparov. Yes, first chess match. Till now, the people was sure that people are please it changed so that people are better, but it was first time. Now anybody who knows the chess, you know that any human is not able to compete with computers, and if there are some tournament, they could be organized only for computers, but people cannot compete with computers. So there were big progress. But I think that, okay, it was again only for some limited community. But when happened something, what changed this was something like 2-3 years ago, when appeared open AI with their chatbot, and now many people start to look, oh, I am able to do something with this AI. I am able to write articles. Of course, if you start to test it, you recognize that you have to be careful, because sometimes this AI start cheating, give you information which is not true, and you has to be careful, because in some cases it can lead to the troubles. But in very short time it improved, and if you have some experiences, now it is not only ChatGPT, there is a number of Gemini, there is number of these different chatbots, and many people who are not computer people finally start to use AI in their everyday work. So this is something what happened. What about Geo AI? I think that till now, Geo AI is much more in the hands of experts. Yes, because there are very nice algorithms for classification of satellite images, for prediction of weather and other. But till now, there is nothing how this to bring really to large community and to become Geo AI publicly available. This is something, and I will a little explain you reason. Okay, now they are already appearing messages that for large language models is problem. There is not more text which could be used for the training. Yes, because these models were trained almost on every text which is available, and now they start to be generate artificial text which is again used for the training. But this can lead, of course, to much more cheating and problem with this. So there is something where is on the top. But how is with Geo? It is completely not true that we don't have enough information for training AI and Geo AI with spatial information, because almost 80% of any information which is generated in the world has in some way spatial character. It is not necessary that it has to be maps and other, but it could be different measurement. Any car is sending information to the factories about the driving and these things. And I read that every day altogether is generate 2.5 exabyte of data. So this is something what is really, really huge. And if we would like to try to use the same approach like is used for ChatGPT, probably it will be very difficult. Now you know that Microsoft, Amazon are buying their own nuclear energy, power station, but it is only for the training of the text tables codes, but to use this huge amount of the data, probably there will be not enough to use all power stations which are in the world to use the same model like is used with this model. So we need to thinking about other way how we can work effectively with spatial information, but how we can bring this information to larger community. So, and especially as in Europe, because in Europe we are much more limited now with energy than is in the US, and also they are not so rich company who will be able to make such huge investment to buy own power station. I don't think that there exists any IT company in Europe which will be able to do this. So we need to look Europe on other way, because I think that it will be not good to be fully dependent on AI coming from outside, yes, because AI can cheat, but AI can be trained also to cheat, yes, and if we will be depend on only external sources, we could be depend on the people who will manage this. So it is also the question of security, to thinking, to develop something what could be used in Europe, and how to put people in Europe in different ways than is now in US, and to work together. So I see now Stelios. He's one from the people who is speaking a lot about the about multi-agent distributed solution. We discussed this with Adra, and also what now we are trying to do in Polyrural Plus is some way where we are trying to combine these different things. Will be discussion about Jackdaw. Yes, it is still now concept. We started to work with this about this in Polyrural project, but later I will speak about Jackdaw on the behalf of Runar, because he cannot be here. So this is one concept, but of course we need to discuss this with broader community to be able to build something new. From the here is the main developer now are Runars and Matush. Matush is here, so probably who will be interested about. And Alex, of course, started as some people helping to Matush. So this is something what we already start, but we need to thinking how to integrate the things. For example, I mentioned these large language models. But what we need, and already in 80s, 2010, Project Future Farm mentioned that it would be good if, for example, in this time we don't speak so much about artificial intelligence, but if some application would be able to analyze legislation and to combine legislation with data coming from the field, yes, and to use this for preparing some advices for farmers and others. So this is some way where we need to thinking how we can combine these things, how we can analyze, test the text. So here are some people. I know that he's somebody also from Czech people dealing with language model, and we need to thinking how we can combine this with other information. I think that it is more from the history, and also maybe about a little about the philosophy. And now I would like ask Alex. Yes, you will take the presentation on the behalf of
Pavel. Thank you, Karol. It was a nice talk, and actually, I will be presenting on behalf of Pavel Kordik, who is actually unfortunately injured, and we wish him speedy recovery. And if you could please put my Pavel's presentation. And I have to excuse myself, I may be a little bit chaotic because Pavel informed us that he got injured yesterday evening, so and he sent us the presentation. Okay, so today I will speak about AI technology in using for geodata. And it's some sort of elaboration on what Karol already said. Because nowadays, we have, since Gen AI is booming everywhere, there is another type of people around us. Yeah, everyone has a friend who is expert in politics, and everyone has a friend who's expert in hockey. Now we have friends who are experts in AI. Yeah, so general public who teaches you how AI should work and what it can do, and usually it starts, but ChatGPT can do whatever. Yeah, and very often LLMs are not enough. And to, to achieve good results in any field of AI, especially AI in geodata, very often we have to dig deeper than just LLM. And as you may heard from Karel, we can't just train the same model we train for language, because language is very lightweight. We can't train the same model for spatial data. Yeah, but there are other approaches, and other approaches that can be applied in for geodata. And here you can see a big list of tasks that can be applied for geodata. And as you may notice, not all of them are language related, right? So LLMs work with language. Language is very lightweight, as you may know, but there are other fields, right? So there are some tasks related to instances, some tasks related to images, or related to individual pixels at the image, right? And those are perception tasks. Also, there are reasoning tasks. And we know that LLMs are not good at reasoning, right? So there are some models that kind of like good at reasoning, but maybe you've heard of the latest OpenAI model O3, which claimed to be really good at reasoning, but one prompt cost $3,000. Yeah, just to get a prompt, to get the output of the model, have to spend $3,000 on energy, right? So you may imagine that those models are not so, I would say, usable for many kind of tasks, right? Especially reasoning tasks. But we have many years of experience with different kind of models, right? So that are very lightweight, good at some tasks, and can be really precise, really good, can outperform humans in many tasks, right? So for example, computer vision since 2014 works better than human eye, right? For other tasks, we have also models that are lightweight, easy to run, easy to train, and they're very good. But there is one thing that LLMs are really good, which is text, right? And using LLMs, we can achieve a user-friendly input and user-friendly output. And what's under the hood, the user should not know. I mean, it's good to know, and that's why we are here, but it's not that crucial what's running under the hood. And here are several examples how to apply kind of this user-friendly input-output on geodata. And if you can take a look at any of those, right? So, for example, here, yeah. So the user asks, rate the image quality, and the answer is bad, right? So, how did we achieve that? So we have a model. We have a model which is not a language model, but which is model that evokes the image analysis, right? So we have a model that, let's say, classifies whether image is good or bad. And then we have some sort of reasoning, yeah, that classifies that it's bad because of the clouds. And this also may be achieved by using this agentic approach, where the agent decides what tool to call under the hood when the user asks a query, right? Here are several more examples that may be interesting. For example, here, if you take a look at this one, yeah? Is there a swimming pool, right? No. We have a model that does segmentation by segmenting. I assume that it's segmenting like image and classifies a swimming pool object, right? So it's object detection. Here we do have object detection of a plane, right? Or object detection in general, and then we classified detected objects as a plane, and then we count them, right? So there are several layers that does the job, not the LLM that does the job. Yeah, and that's actually even classified Tesla Model Y. Yeah, you can see several tasks can be used for this. Yeah, just I think there should be one more. Yeah, yeah, yeah. For example, this one is what is the population of this urban, right? So, can you guess how the count was made? I know one person who can guess, but at least one. So we probably call an API that has information about this area, right? And the information can be from whatever government pages, and yeah, we just grab the information. But there is no chance that LLM knows the amount of people living here. This one is also very, very interesting, right? So it actually extracts physical property from the image, right? So it says that the boat is in motion or ship is in motion. This is actually very simple, yeah. But this can be also applied to things that are more complex. For example, we can extract some properties of the motion from geodata, yeah, to be able to predict, let's say, further motion, right? Or to be able to extract physics of the motion, because the thing about most AI models that they are really good at memorizing, but no, they're not very good at extrapolating. They're not very good at predicting the data outside of, let's say, I don't want to say training set, but training bubble, right? So if the distribution of test data is different, then we have a problem. But introducing some sort of physics in models can help drastically in improving the reasoning outside of the distribution. And this is another interesting thing, another interesting topic that we work on. And by combining these things means combining this fancy Gen AI with our expertise in various AI application. We can actually achieve pretty good results that are, I would say, state of the art, and that do not require a nuclear plant in the backyard to fuel it, right? Here's some example of Gen AI things like video generation. And video generation is actually mapping text into latent space, and from latent space we have a video. Yeah, so it's a visual encoder. So that's a some sort of transformation, text to video, and so on and so forth. So it's multi-domain. And as we know, geodata are also multi-domain. In this case, we try to combine these multiple domains of data, means satellite images, weather information, and so on and so forth. And then we are able to grab the most from these multi-domain images, multi-domain data, And in order, doesn't work properly. Oh, yeah. In order to achieve good results, yeah. So there are several related AI technologies that can be used in Geo AI. We know that it's multi-source data, it's multi-domain data, and there are several neural network architectures like autoencoders, UNet, visual transformers that all contain well, that's all form of neural networks. And here's an example of image super resolution that can be used for example, weather super resolution or satellite image super resolution, or also next frame prediction that can be used for prediction of cloud movement, of weather, of some object movement, and so on and so forth. And like by combining all this sort of data, our lab, which is a data lab at Czech Technical University, could achieve some, I would say, state-of-the-art results. And I will give you I'll give you an example of a success that was achieved by my colleagues. It was 2 years in a row, which is an international competition weather forecast. And here is an example of precipitation prediction trained on a small region and predicted on a different region. So it contains some sort of transfer learning that can help to reply the answer whether we can train on one place and predict on the other place, right? So it's kind of what I was mentioning. So if the test set distribution is different, and the success was mainly achieved by using a combination of several architectures of neural network. In addition to regular neural network that is meant to learn the train distribution, a special neural network was used here to learn the physics, right? And by combining physics and classical neural network approach, well, actually, it was like several neural networks working in ensemble, but the big success was achieved by using this FIDE-net, which learned the physics of let's say physics of rainfall, yeah, in time. By adding this physical properties or physical nature in this neural network, the success was achieved. Okay, so here's some results. Actually, in the original presentation, it was a GIF, but PDF does not allow GIFs. So it's have to trust me. It looks good. And oh, sorry. Here's another example of radar images, radar or precipitation prediction in time that used by the company Meteopress, that's a Czech company that actually sells radars, and the algorithm is developed by my colleagues, and they believe to be the best. So that's okay. And our current focus, as I mentioned, is combining all sorts of data, including physics-informed models, and introducing small models that are very good at reasoning inside large language models to make it user-friendly, to make it easier to use, to make it cheaper to use. And thank you for your attention. Who's next?
Alex, thank you. For the most, thank you for keeping up with the time, because we have plenty of more presentations to come. Karel, would you like to introduce the next one?
No, but you would like to mention that you would like to tell something about it.
Yes, I needed a few words that I forgot to tell them in the first part about the organization of the event. All of the event is possible because we have the European Digital Innovation Hub that is supporting us in being here at the premises and at the event. So we thank European Commission for the trust that they've given us for running the European Digital Innovation Hub. Karla, díky.
Thank you. I will speak again, but I am promising that it is my last presentation, and it is not in principle done by me, but it was prepared by Runar, and it is really some presentation of some ideas and achievement from Polyrural Plus, where also other people cooperate. Runar is in Asplanviak, Czech Technical University, CCSS, MAC. It is not mentioned PSNC, who is also involved in this. So it is some basic of the common work, and it is one from the things what about we would like to work more here. I already mentioned that from the programmers, mainly Matuš is here, and I will again go back to large language models. Something was in some way mentioned by Alex, but if we will start to ask large language models about some places, yes, it really depends which places they are. If we will ask something about, you can see here some icons of big important cities, probably you will be able to receive some amount of information about these places, yes, because there is a lot of sources on Wikipedia, on internet, and all this was used for training of large language models. But the world is not only about these popular places, yes. You have there many places, you have there which are collected with a huge amount of the data. I mentioned this in previous presentation. And if you will ask on something, in many cases you will receive some information which will be all really very generic, or you will disagree with this, because there is huge amount of really places which are not well described. As for example, if you will see this village, it is the village which is origin of Runar. It is anywhere in the Norway. I think the name is Labaken, if I am true. And if you will ask about this village, if you will ask about the fields, probably the information will be very generic, because there will be not many information which could be used for training of large language models, yes. So, and if we are working for the agriculture, for the planners, we need to have communicate about such places, yes. What can artificial intelligence know about this, and how it could be able to recognize this without analysis of geospatial data. Yes, probably if you will look on this and if you will provide it some classification of images, you can recognize that this area is mainly covered by forest with could be some meadow, and if you will ask some other different geographic source, you can recognize that it is a really mountain area. But without this, it is difficult to have some clear answer. So, as I already mentioned, we need to thinking how to tell to large language models or language models, because we now start to use ChatGPT as the language model with which we are working, but our idea is to have some interface, could be for smaller language models, which will be trained to communicate well in English, but then will be served by information about local places. There is really number of application which needs this. Yes, Polyrural Plus is mainly working about regional policies. Yes, so we need to know most about every region, what is there, to know the details. Yes, about the land use, about the industry, about the tourist facilities, and to be able to provide eventually different assessment and reasoning, as already Alex mentioned. And if you would like to ask something ChatGPT, usually you will receive this information that he don't know more about this area, and if you would like to have some better answer, you need to serve him by better text, by better data. Yes? For example, if you will ask if this region is suitable for production of potato, probably the answer will be I don't know. Yes, other things is that, of course, the same name could be on many places, and if you will ask on some names without geographic context, probably you can receive the information about completely different areas. Yes, because without this geographic context, this large language model are not able to recognize which blue mountains are discussed. And if you will, for example, asking about some nuts region, I don't know if it is trained, this large language model, but for example, if you will ask for some concrete field about the situation in the field, language model is not able to answer because he didn't know anything about this field. Yes, so there is many potential question where large language model cannot help you, but of course the type of interface when you are communicate with information system, with artificial intelligence by natural language, is something what can help to many people to be able to use AI. And so there is the reason why we need to thinking about this. And here is some concept of this Jackdaw, which I already mentioned, where we start to thinking how we can do this and what could be done to be possible to integrate this different type of analysis. When you are making some question, the question is parsed and is analyzed what about is, and if there is some, could be geographic topic and something what is relevant to some type of analysis, we have the catalog, and we are looking to the catalog. If there are some data which can help us to answer this question, or data or services better, yes? So we have to look, this data or services could be maps, but it could be also the text, yes, because I mentioned in my previous presentation, for example, some legislation, yes? So we can, we need to have some catalog with artificial intelligence, which will be able to recognize which data sources and which services could help us. And then when we are doing this, we can ask for this analysis. It could be distributed on many places. We can eventually analyze the text. And this result are sending back to large language model. And then a large language model is able to interpret this answer and generate text data. And also our idea is that in the future we will be able to add this into the context, but also we will be also able to, for example, visualize this data to generate new maps with artificial intelligence, etc. So this is the concept of Jackdaw, which we start to work last year. There is some prototyping. I think that now is, Matuš, already version 2 available. So we have because at first we started with few data sets which were an analysis which was really fixed. Now Matusz with Runar work in last weeks very hardly on this be able through the API connected different analysis and to start to building this catalog. And this is one from the things what we would like to work about here, because this is from our point of view the way how we can with could be relatively limited energy power, relatively limited financing to reach some good result. And if we will not try to have this jackdaw focus on any problems, but if we will target on some concrete problems like spatial planning, like agriculture, then could be with much lower energy demand, prepare something what could help people to solve their everyday problems. So we are on the beginning, yes. We start to work. We would like to cooperate with you also on some ideas, some future prototyping. I am happy that we have here people from standardization, because of course this is also about the standard. And you know, any AI need a lot of training, a lot of data. And so this is the reason why we are first time here, and I hope that it is not last meeting where we are sitting in about this problem, and that we can continue in the near future. So this is our challenge for Geo AI Camp to work, and there are some ideas. So there is enhanced user interface for Jackdaw, enhanced data catalog that identifies which data sources, tools are relevant to the question. This starts in a Polyrural Plus, but Raul, I think that this could be something what is also very relevant for FAIR to adapt project, and what you are doing with your technology. This could be question. We need to extend the data services, add more analysis, for example, thinking how we can add routing, logistic, and different contextual analysis. So these are some ideas what are here. Unfortunately, Runar cannot be here due to the fact that he has to move his mother to the doctor for some operation. And in Norway, it is very different than in the Czech, because in Czech we believe that we need to have hospital in 20-minute distance. He has to move his mother 5 hours from the countryside to the hospital. Yes, so, but he promised that during afternoon when he will, and tomorrow when he will be in the hospital, that he will try to sit and connect eventually with the teams and work. Matusz is here, Alex is here, so I am sure that from our side there will be good progress, and I will try to generate some crazy ideas, yes, because I mentioned that I program in 80s, but now I am not able to program, but I am able to generate some crazy ideas, so this will be my role here. I would like to thank, and now I would like to ask Peter. He will have 2 presentations related to second our project, and it is more really focused on usage of different type of analysis.
Thank you, Karel. Hi, I'm Petr Šimánek from Czech Technical University, from Faculty of Information Technology. And I'll be speaking about 2 topics that we solve in project called Aliance. This project is from Czech Thatcher, Czech grant agency. And we are focusing on 2 different topics, which are both connected to AI and agriculture usage. The first topic is weather forecasting. In this case, we call it hyperlocal weather forecasting. It means that we are directly focused on one particular space, or one particular area. So nothing huge. Like right now, there is a huge revolution going on in the world of weather forecasting. Google, Microsoft, Nvidia, all these huge companies are paying a lot of money to improve weather forecasting, but they are focusing on very global models, very global products. Let's say they create model that tells you what will the weather be in the whole world in next 2 weeks. But most of the people, they don't really care about this. Most of the people in the world, because you don't care what will be the weather in Antarctica tomorrow. But you care what will be the weather exactly where you are. And for agriculture purposes, this is even more local, because you have very different weather on top of a hill, under the hill, close to lake, or on the sunny side of the hill, and so on. And agriculture people, they usually use weather stations. They plant weather stations on their fields, and they want to predict the weather exactly there. So they don't care about huge global Google models. They care about their particular field. So we decided to help them with this, and we decided to use many available data, like historical data from their weather stations, some other numerical models, and we learned how to combine all these in one particular model. And this model can give you very accurate prediction for exactly the place where you want it to be. I spoke last week to the guy who owns Yacht Club. And they are also very interested in this solution, because they want to know what the wind will be in their particular yacht club, and they don't care about anything else than just wind in this small bay, and that's it. So we can help them. We created this model that consumes very different modalities of data. So from global forecast, from US model, or German model, together with the weather station and other data, and we merge all these data into some not so complicated architecture, AI architecture, that gives us the forecasts. Here you can see, hopefully you can see, maybe the best thing is to look at the wind speed, which is this row. So this is prediction from the standard model that you can see on your web pages or on your cell phone. And this is part of our model. Sorry, this is the ground truth, and this is our model. So you could see that it's much closer. When we look at the errors, so mean absolute errors for different variables, we can see that this is the standard model that you can use, and our best model right now is this model, and we are still improving it every time we have better data, or we are trying better and better architectures to improve the results. And yeah, so this model, it is easy to create, easy to deploy. So right now there are like 200 something weather stations in southern Moravia and Slovakia. Some are in Slovakia that are in vineyards, and we are doing this prediction for them. And we are looking for cooperation, so we would like to find yeah, we would like to improve the integration into current weather stations, systems, and platforms. We are also looking for ways how to improve the data that we are ingesting into the models, and we are also looking for new areas or new application areas for this problem. So this was the first talk, and the second one, if I can ask you. Thank you. Yeah, and this is the second part. This is very different AI involved. We are trying to remove clouds from satellite data. Very often, people working in agriculture, farmers, they use satellite data to assess the state of their fields, to find out if they should add fertilizers or if they should do something with their field. The problem is that the satellite data that they are using are most of the time like image data. So this is just image from the space, and sometimes it's cloudy. And you find out that it's cloudy most of the time. So it's very difficult to say something about your field because you see just white or white-gray blobs, and it doesn't. Yeah, this is something that can happen. This is not a missing image. It's just it really looks like this sometimes. So based on this image, you can't say much about about your field, which is a sad thing. And we know that this cloud cover is a problem. We try to remove these clouds using AI, and we do it by joining multiple multiple types of data, multiple available sources. We are using mostly Sentinel-2 data, so these are just images from the space. Sentinel-1, which is also satellite data, but this time it's not image, it's radar data. And we add information about weather, soil type, crop type, land use, elevation. And we merge all these data to develop new solution that would give you images like this. So nothing, no white color, no clouds, just something like this that gives you information about what your field looks like. And we are trying many architectures. One of them is based on, like the latest one we are working on is based on diffusion models. So if you generate images using DALI or Stable Diffusion or any ChatGPT model, you use something like this, so similar architecture, but this time we don't create lovely images of cats, but we create images of fields. And we have various results, so you can see that these are the inputs. So this is input from the radar from Sentinel-1. This is input from Sentinel-2. So you can see that this is like white something, and we can see that what the farmers usually use are NDVI, which is normalized vegetation index. I don't know what the D is, but it just tells you how much green there is, and we are also predicting this. So not only we are able to remove the clouds, we are also able to look bit further into the future and then tell the farmer how will the field behave in next 10 days, 15 days. Yeah. And we have quite nice results also for, we call it transfer learning or or generalization, because we were able to apply these models which are trained on Central Europe. We were able to deploy them for Colombia, and it worked quite well as well. And right now we are in the afternoon and tomorrow sessions. We are looking for new applications. If there is someone interested in applying new architecture to these data, we are also interested. Or we can think about new data sources for this kind of or anything else. Thank you.
Okay. So you had chance to have some idea, and now I would like to ask Aaron to present it semantic enrichment services, which I believe will be also in future integrated into Jackdaw.
Exactly. Thank you. So, hello everyone. My name is Aaron Rynkiewicz, and together with Raul Palma, we are from Poznań Supercomputing and Networking Center, and I am going to talk about semantic enrichment service and also retrieval augmented generation pipeline, which are both tied to the Jackdaw service. So the main idea is that for semantic enrichment service is to have end-to-end entity linking, relay extraction, and to show how it looks like. It's basically, we have text corpus and we want to extract key information from it. And this is the first point. So to run end-to-end entity linking. The main idea is that human language is not very precise. So the example that we have before, that blue mountains, probably there are a lot of blue mountains on the world. In the world. So the idea of the first step, so end-to-end entity linking, is to disambiguate those terms, those entities, based on the context on which they appear. And those are vertices in our graph. And then we run relation extraction to extract relations between those entities. And this way we can create basically knowledge graph based on the things that appear in text corpus. And why is it important, especially for example for Geo AI? Because we can place, we can add data to the, add even more data to the given place. For example, here on an example of Prague. And we can extract this data from unstructured text, and there are a lot of unstructured text. So of course, this is very important. And the second thing is that everything in those processes are backed by LLMs. But the important thing is that we are focused mostly on open source solutions. So we are using local LLMs, something like Mistral, Llama, DeepSeek. This is our interest, so no OpenAI. And the second, this also applies to the second thing, so retrieval augmented generation pipeline. For the people who are familiar with LLMs, this is very standard topic, but just to summarize how it works, we have documents or a lot of documents. We use it some kind of method to split this document into smaller parts. So we have chunks. Then we embed those chunks into vectors. And we use those vectors to store, we store those vectors in the vector database. And then when a user asks a query to the large language model, we use it, we pass this query to our vector database to retrieve the most suitable chunks, which probably contains data relevant for the user question. So this is the way how we can basically maybe not remove, but not really remove, because we cannot remove hallucinations from LLMs, but to lower a chance of probability of this happening. So we can basically add and also add knowledge to LLMs. So this is the second thing. And as I mentioned before, we are focusing on open source. So this chunking or vector database is all open source. So ChromaDB, or for example, Llama for chunking, and also embedding models are also open source. So this is our main focus, and basically that's a quick presentation from me. Thank you for your attention.
Thank you. I think that we agreed that it is common for both Aaron and Raul. So I would like to ask Stelios, please.
Thank you, Karel. Hello, everybody. My name is Stelios Kotsopoulos. I'm representing Neuralio AI, and I will talk you about what we are doing on the project transition that has this title, EO-informed agent-based models for digital twins applications. So before I start, Karel told a bit that, you know, we believe in the distributed systems and also the competencies between different agents. Although someone cannot consider me as a socialist, I believe very much in the collective intelligence, because at the end, now in this workshop, we will discuss for both days, today and tomorrow. We will exchange some knowledge, we will fight or actually arguing about different topics, but at the end, collectively, because we are on the topic, we will be more wiser in the Wednesday. So, the current Earth observation, the AI Earth observation landscape, I think that all the previous presentation, more or less, gave you what is happening in the topic. So, we do have a lot of different algorithms analyzing satellite data, analyzing gridded geospatial data, providing some information either for specific locations or identifying patterns between different locations. So this approach actually is not something new, because the last 20 years, at least that I'm working in the field, we are working machine learning applications to this sector, either to monitor land uses, to identify climate patterns, also to start doing some predictions. But every time, the problems that we are trying to solve, it was not so complex and requesting this flow of information coming directly and identifying emerging patterns that is not present with the typical AI systems. So something that is important is the predictive analytics. How we will see this system is evolve, how these systems are having variables, depending on variables, that they are interacting each other, and how these systems are actually transforming their environment, and the environment are shaping their behavior. So we are talking actually for autonomous systems on a specific environment that it's not also a new concept. It's the typical multi-agent reinforcement learning framework that already exists. This provides a lot of opportunities for climate adaptation, resource management, policy design, early warning systems. We get funded from the European Space Agency for this project in order to develop a system that it will allow the policymakers to make more informed decisions and data-driven policies, that they can use this digital twin to identify or to measure the impact of their policies and to quickly making some corrective actions in order to make the systems better. So we are talking actually for solving optimization problems and also some prediction problems, optimization, because we need to see which is the optimum solution of the system based on the question that we have put in the system, and also we need to predict the complex behavior of the system in order to identify which from the future scenarios will be the best to use. What we need such a system to work, first of all, we need to make the typical that digital twin for this topic is needed. So data collection and continuous streaming of this information coming from Earth observation, but also from socioeconomic and policy data, because as I told you, we are talking about data-driven policies. So we need to have this information and we need to integrate it in the system. The other one is the AI and machine learning, of course. Somehow we need to use such kind of algorithms in order to predict the future states of the environment, but also to guide the autonomous agents on this environment, because the autonomous agents is having already as their soul some neural networks. The multi-level agent-based modeling, actually it's a multi-level because you do have actors that they are going to take some decisions in different levels. So it starts from the ground, let's say the first level that we have from the farmers, for example, that they do have perhaps some competitive land uses or competitive crop cultivation. The second, the mid-level, it could be someone cooperative or someone that is actually grouping these farmers and forming some new type of agents, that it will be an aggregation of the previous ones. And of course, we have the high level, the high level of the agent-based modeling, where we have the policymakers, and they want to see all the different levels of the different agents and the groups. So then we go to the scenario simulation, and of course it provides us some actionable insights. I would like to have a lot of time to say and explain and talk more about the system, how it's working, but let's go directly of how it is work and how we are using both large language models, reinforcement learning, and also the whole architecture of the system, because we do have some two major challenges. The one challenge is how you communicate this information with the users. The users of the system are not some technicians, some specialists in the area. There are more or less people that do understand about the technology. They knew what they want to ask the system. They don't know how to do it. And from a commercial perspective, if we try to cover all the potential users, perhaps we should create, I don't know, some 1,000 different UIs in order to cover the different user needs. The other thing is that always we need to have an expert to setting up the simulation scenario. So all the tools, it's used for many years, but which is the problem to make it this used in to scale up? It's always the issue that you do not have a lot of experts to setting up the simulation scenario. You do not have the ones that they do understand about the complex systems and to make the optimization procedure. So what we did is we use an LLM, the Mistral Mini, actually, we use to communicate with the user. So the user has a chatbot that actually describes which is the problem. And the LLM actually guides the user to help them shape the problem. And the other one is asking the information that is needed from the user. So it guides the user to select the area of interest by opening in the UI next to the chatbot, a GIS map where the user could actually draw the area of interest and provide information. Also, it could upload some information like a GeoJSON or some other things that it is requested. All the others are directly linked with the Destination Earth initiative, so it grabs the data from there around what it is shaping the current state of the environment and also the satellite Earth observation data. The second part is that we need somehow to have the AI agents, the AI software agents that will be the experts in order to setting up the simulation, so to prepare the codes and send it back. I think this is to send it back to this part in order to execute the simulation. And of course, because this part is very heavy computationally, when the results are ready, are then going back to the workers and they are communicating sort in MongoDB and also communicated through an email to the user that the results are finally there. Then the user, after that is taking the results, it could work again on the same chatbot in order to analyze the result, either to see it in the graphical user interface, the graphs that it was produced by the system, or to start writing the report, because in many cases for the policymakers, the final output is a report that contains all this information. So this is some about how the agents and the reinforcement learning is working. I don't know if I do have the time. Am I okay? So if I do have the time, it's very simple how it works. Imagine that I am an agent. I'm here with you. You are the other agents that we are interacting each other. I'm making the presentation. You are hearing the presentation. And we have also the environment, which is this room with specific temperature, humidity, level of noise, and everything. So now you can hear my voice. If someone else starts speaking, it will interrupt me. I will answer back. And this is an interaction. This interaction is not only change what we are doing and the decisions that we are taking, but is also changing the environment that we are operating all this together. According, if it is offering something that it could be, let's say, useful, all this discussion, it will be a reward. So it is coming back to the loop, and we are continuing this discussion. If it is not so pleasant, all the discussion, it requests an action that it will not, for example, if we are all talking and arguing for something, it will have a lot of noise, so it will not pleasant. So in our conscious, we will understand that this is not good and not to repeat it again. And this is the reason how the reinforcement learning is working. The system, it will be ready and launched on 8 March, early April, because we are obliged actually from the Space Agency. It will be also hosted in GitHub as open source to be accessible from everyone. And I will be glad to see you all users and testers of the system, at least in the part of the chatbot, playing with the chatbot, to see if you can confuse it, or at the end it could provide the information, or it could guide you and explain to you how you can use the system. This project, Neuralio, is the prime contractor and chartered private company, the wireless info, here with Peter Horak and Asplan VIAC, we are working together under the European Space Agency to make this one of the main mechanisms of developing digital twins and for the destination Earth, and helping the users to setting up scenarios that is not only considering the gridded data, but also to put inside the socio-economic variables. Thank you very much. Thank you for your attention. I'm sure that I violated the time, as always.
Okay, no problem. And I mentioned at the beginning that we have here also OGC Piotr. He will tell us a little about the OGC, because OGC could be play a very important role in standardization of Geo AI.
Yeah, by the way, I'm not sure if it was a typo or maybe this is Geo AI Ordnung or something like that. Maybe we're talking about this level of applications. So yeah, the OGC, I'm not sure how many people heard about the OGC in general. Maybe I will skip this fancy introduction that this is community. We are building standards. Actually, there are several members of OGC already in this room. So thanks all of them that contributed to this ecosystem. OGC has been set up 30 years ago already. And those who are dealing with the geospatial information, like first applications of the web portals that are maybe not Google, have used probably some of these services like OGC web map service or feature service. And now we are, yes, one of the trends is Geo AI, so there's a lot of talks about that in this community. Few of them I will mention here in the, let's see, proceedings of the last gathering that took place in the fall. Next OGC member meeting is, by the way, in Europe, in Rome, March. So everybody is invited to take a look on that. There's also a new model of membership introduced that leverage a lot more developers and personal contributions to the OGC community. So yeah, in this context, we talk about as many cases of the Geo AI applications. So putting that together, we think about that like there are two main aspects of that: the AI that's applied for Geo, and Geo that provide the knowledge to the AI, and allows to this inference and using this information. Is it changing? And this case is very similar to what we've seen already today. So this workflow of the LM supported assistant that helps you to determine the outcomes, to even generate the maps. So that's also something that Carl mentioned. And why it's good that it's here, because if we have this several ad projects that are converging to the common solution, there is also always a question, okay, so how mature is that? And shall we actually agree, let's stabilize this level and work on the advancements of this? Can we use it? Can we reuse it? And in the end, who do we provide this for? So depending on the end user, there could be some implications, like we are doing this for the decision makers. Maybe they are interested in the trust of these models and really the quality of this information. If we are dealing with autonomous systems, maybe they are not so much interested in the research, but they're very much interested in the accuracy of the information we are providing. And there's been the concept that was coined by EO community several years ago, and the frontiers were naturally those who implemented it. But nowadays it's applied more and more in the applications, in the digital twins applications. So already this large infrastructure are implementing those. And I think that this is also an opportunity for this European community, because we want to compete with on the global market, and we want to build solutions together. So reusing the applications, reusing and understanding what is the outcome of that is really, really important. And we are naturally using many data sources. So it's always good to understand, okay, my model was trained on what data? We talk about reinforcement learning. It works in some cases. It works better in some or less in some other cases. So a few years ago, it was said, no, really, you shouldn't use the same model trained in the one region in the other region. Now it's more diverse. So we see that in some application it works, in some it's not, but we need to understand it. And there are naturally these trends of the democratization of these web services. So I don't know, 20 years ago maybe, when the OGC services were built, were in this phase like Geo AI is maybe now, because it was built by experts for experts. There were a large community of the users who really didn't get the sense of what's happening inside. But those who implemented it were mostly the experts. And now it's changing, so we have more and more these easy, accessible services. It's going into the APIs, which means it support more the semantization, the knowledge graphs, but also it's extending the models. So we see in the Geo AI community, which has now set up the working group, was actually starting from very simple concepts like this train ML. So this train ML is really showing that you have your model and you want to share with somebody, you need to describe it well. And there's a number of parameters you can agree on that are useful for this community. So there are many use cases. I just mentioned here some of them that were top of my mind from the recent experiments and some of the papers that were presented recently. It's about the harmonization of the data. So the web services are now understood as the ecosystem. More and more it's treated as the data cubes, not the services itself. So regardless of what type data is behind, we are accessing data as the cube. It's web optimized in the sense that it can be accessed by the web. But in many cases, this web optimization is also suitable for the distributed systems, when you really need to leverage the tiles of the data and process it in this distributed environment. We're thinking how to fit the LLMs. So really, there are many of these flavors that people put on top of the services to make it more understandable by its AI, like LLMs. And we are talking about the annotations of this whole pipeline. In the past, there was quite huge adoption thanks to the whole Inspire program. Regardless what you think about the Inspire, it really leveraged the interoperability in Europe about this geospatial information. And we see that more and more communities are sticking together. So there are people from the Stack community, GeoParket community, which come to OGC and are welcome and have the support. And really it helps them to leverage their standards into this wider context. Yeah, so thank you for this 5 minutes. I think that was enough.
Okay, thanks, Piotr. I am happy that I can say that now we started 2 projects with OGC. It is Bioclima and Focal, so it will be possible to cooperate on this. And I would like to announce other things. Peter, in his presentation, mentioned that some of the our experiment were already tested in South America, in Colombia. Now we probably will introduce the project with Africa, and I hope that something what is here done could be also tested in the near future in Africa. So, please.
Thank you so much, Karl. Yes, Africa, you just said it. So we are WASYEP, and a small non-profit organization. I founded nearly 10 years ago, a bit less than 10 years, working on IoT. And this is for going forward, right? Okay. IoT, edge, and AI solutions for agriculture in Africa. So this is, when we started, I was saying 10 years ago, this is what we started with, the devices, right? IoT devices, long range, communicating with radio, low power, and low cost, which is very important. All right, so those devices are communicating with the WASI edge. So it's an IoT gateway that you put on the farm, for example. Here is the model. This one is the autonomous version. So it's using a solar panel, batteries, 3G communication, and it's collecting all the data coming from the field. All right, hundreds or more devices deployed in the field. So the devices you saw before, which are quite small, working on batteries, autonomously. And all the data is collected here. And it's called WASI Edge, because it's an edge computing device. So your AI models, I know that you are AI guys, okay, so your AI models will run here, not in the cloud. So how does it work? Let's say an example, and this is what we will be working on, AI for agriculture. So here the Geo AI guys will provide this, the satellite image, all right? And we will mix those satellite image with the sensor data coming from the sensors and also with weather predictions together to get what? The state of the crops, the soil conditions, okay? For having and so we will use this predictive analytics running at the edge. So in more details, this is your edge controller here. So this is what we call the WASI edge. So the AI model is running here, okay? And we will see it in more details in the next slides. And the data is coming from what we call the smart tensiometer. You will see a better picture after. So the smart tensiometer is getting the humidity of the grounds along with other data and transmitting it to the gateway where we run the AI model. Okay? We also collect space imagery on the edge device, and we collect weather predictions. And this allows us to create a local model, which is created locally, and then to perform the inference at the device level. This is some preliminary results. So here you can see in the ground truth in green, and in blue, this is a prediction. So it's rather close. Okay, and here's the model. Yes. So not going into details because I have only 5 minutes. This is what is running on the gateway. So as I was saying, not in the cloud, at the edge. So first of all, there is 2 steps. The processing, because the data coming from IoT in particular is not very clean. Okay, so there are missing data. Sometimes you have a lot of calibration to do. Here also are the steps of data scaling, normalization, probably you know better, the data transformation, the formatting of the data, and then the modeling. And here's the, one thing that we do, which is quite particular, is that we do the model evaluation also in the gateway. So we are running various models, around 6 or 7 models that you probably know they are quite classical. Gradient descent was telling Karel before that he was doing many years ago. This is running in the gateway, and we are doing the evaluation locally and select the best one for this local field, okay, and use it in the device. This is our deployment, and you can see here the device. Here, if you zoom with your eyes, this is a device. It's a simple pole that you can put in the ground. It's very easy to deploy. There is a solar panel on top, so it's autonomous. It's communicating with radio, LoRaWAN protocol, for those who knows. And the sensor is directly below in the ground. Okay, so it's one of the projects that we have. It's called Osiris. Okay, and I would like to conclude with a completely different topic. We have this training center online platform, which is using AI. And let's go to the next. This is generative AI, in particular for the agri-tech education. So all the technology that you saw before, it needs a lot of trainings, right? And we are deploying this training also in Africa in different centers. And we would like to use AI generative AI for two purposes. The first is to create the personalized learning path for the students, so to accompany them on their knowledge journey. And the second is also to prepare the content in the local language. So we are looking for partners. So some of you, if you are interested, you can come to us. I'm here with my colleague Abdul Rahim. Okay, so we will be available. Thank you.
Okay. Thank you. Now we again will go to the Greece. So we have here Odyssey.
Thank you. Hello to all. I will try to be brief. I will present methodology in the context of Scale-Like Data project. It's a Horizon project for crop classification. A little bit about the project. This project aims to understand and refine how complex farm level data streams are governed, organized, and managed. It also focuses on technologies to scale the local farm data into larger regional datasets for environmental monitoring and production management. It has 6 research and innovation labs that will develop, test, and showcase how integrating near real-time sensor data and can provide improved monitoring capabilities. And so these RI labs will drive innovation covering different regions of Europe that are biogeographical different zones. And in the next slide, the lab that will focus is the crop management lab that will create from New Republic. It's my company that I work on. This lab will create a mechanism and a governance plan for collecting IoT and farm log data at the crop level and aggregating them at the regional level to support policymakers in making decisions. It will implement a user-friendly navigation from municipal overviews down to individual crop parcels. The potential users may be farmers, agronomists, and policymakers. And in order to go from the local region, from the local information to regional information, there is necessity for crop type classification. And this is a general methodology that we follow. So the final aggregated regional indicators, for example, the pesticides that were used, irrigation, or the yield per hectare, and so on, these informations are really important for policymakers. So the architecture of the system will be something like that. This is, I have to say, that is an ongoing work. Now we are starting to work on this. So it will have a website and a lot of external data sources and data sources that we have from the crops. We have installed sensors on the crops, and we have also information from the farm calendars. So having all this information, we can we can present them to the various users. For the crop classification case now, we have information from parcels that there is installed sensors, and also we know what exactly the crop type it's there. Then we have a more extensive region for a group of parcels that can be used as a control parcels, and then we estimate or we reason about the crop type in a broader region. For example, this is the municipality of Lasithi in Crete. This is real use cases. What we use? Okay, we use the well-known support vector machine with radial basis function. So to train this classifier and produce the crop classification, we use data from the parcels, from polygon geometries, crop type, growing start season, growing end season. Along with Earth observation data from Sentinel-2. We use 5 bands, the 3 RGB bands and the 2 near-infrared bands. So for every pixel, we make a signature, for example, from all these bands. Other data that we use are the boundaries from the local administrative units, for example, the municipality area and so on, and also for other land use data, in order to exclude some regions that we know for sure that there is no area with crops like that. For example, water or trees or urban area, etc. So this is the procedure for the classification. We have some parameters for the algorithm here. And this is the result for the whole region. As I said before, there is an ongoing work. This is an ongoing work. We have a very initial proof of concept. We are currently working on validating the methodology on large-scale data sets for the whole municipality of Lasithi in Crete, in Greece, for potato crops. Of course, there is a lot of space for future work. For example, to train multiple crop types within the area of interest, to include in the workflow the phenological stages of the crops, for example, the leaf development, flowering, season, so on, along with the Sentinel data. And of course, to investigate additional AI methods and algorithms for deep learning and so on. So, thank you. If you need more information, you can contact me, or you can find in the Scale-Like Data website or in Neuropublic. Thank you.
Thank you very much. And last but not least, Honza, please, as I understand, you will introduce regional data, yes, Atlas.
So, hello, my name is Jan Horak. I'm a large language model expert, and I work with AI for past, I think, 8 years. I studied here in FIT and FEL. And right now I'm interested into developing AI models and using LLMs in chatbots and working with vector databases. And today I would like to talk more about not technical stuff, but more about vision, how I think this year will go along. I don't know. Okay, the slides are not working, but can you please? Okay, thank you. So what I think the current vision for this year is mainly about about copilots, because I think large language models are very good at one thing, and that is coding. It can write very good code, and it can do it efficiently. And right now, for example, OpenAI has new models like O1 or O3, but there is also DeepSeek, and this is 60 times cheaper. So I think it's very promising that this year everybody will have like OpenAI or open source model in his own phone or in his laptop, and he can run models very efficiently. And I made a small presentation, small demonstration about Atlas, that's local regional specialties. Can we, okay. So I made a small simple demo that is using vector database, and it basically processes the Atlas data from JSON. It puts into vector database, and then it creates a simple chatbot that can be used for interacting with user and explaining his queries. So we can go to another slide. I will skip this technical stuff right now, but maybe we can play the video, please. Okay, so here we have Atlas. It's a website with farmers. I wanted to do it live, but I made a video because it was not possible to plug in the computer. So here we have Atlas, and I made a simple plugin here, and that is a chatbot window. It has the knowledge database, and we can ask any question we want. For example, we can put some predefined question like, what are some producers or farmers that specialize in delivering milk? So the AI will check with the vector database, and it will give us some, I don't know, 3 or 5 results, and it will put into the GPT and synthesize the response. It works in any language. So for example, if my query is in English, then my output will be in English, and we can double check if it's not hallucinating. For example, we can use this Copilot plugin in any website, for example, here in Atlas, and we can see it correctly identified. For example, this one is producing 800 liters of milk, and it has like this type of cow. So yes, we can add any question we want. For example, what place, or in Czech language, what place is suitable to go for a family trip, or for children for one-day trip. And again, we are accessing the vector database, we get the results, and GPT or any other large language model will synthesize the output. So all the data are put into the vector database, and it can be used to query the data. And another bigger step, as other colleagues said about Geo AI, could be running a code that could make some simple input, like access a relation database that will query, for example, GPS coordinates, and it could interact for us with the map in if we allow to execute a code on this website. For example, it could run some simple JavaScript query that would move the map or show us some other information or mark some region we want to ask about. In Šumava, how many farmers are there, or what's the total, I don't know. It can be basically any question, and if we connect the correct API or correct data, correct databases, then it can give us some interesting results, and it can be also easily connected with live data. For example, we could make it so that the agent could scrape data live when we ask a query. It could find another other relevant information on website, for example, with some scraper, and further augment the data. So we would collect, okay, this farmer posted something on his Facebook or on the blog post in past week, and we can add it to the question. So we can easily explore and use large language models very efficiently with integration to some platforms like this Copilot here. So, thank you. Any questions?
Okay, thank you. I think that it will be very useful if you will speak later during the coding with Matusz and other group, because there are very similar approach about this. I would like to make a few information, yes. Before now will be some lunch, then we will go to the rooms for starting to doing some real work. I would like to introduce at the beginning mainly the people, because one part what we prepare, of course, there could be established team for other problems, but what we define number of challenges is related to Jackdaw. So. Matusz is one from the person who probably will be involved in more things. Dima is some persons who is doing a lot about data for Jackdaw. Alex is some supervisor for this, so probably, of course, for single things, Petr and Jan probably will cooperate about the integration of the Atlas. We would like to discuss how we can use LPIS as a data. Of course, there is second part which will be focus more on this, could be Allianz. This is this image processing and forecast of weather. So Petr is here. Okay, so who will?
Alex will do.
Yeah, so Peter, unfortunately, he's not here because he had to go to hospital. But for satellite images, Matej will be responsible person, yeah, and Jirka will be responsible for weather forecasting, and I will be dissolved in between these groups. So thank you.
Of course, there were some additional ideas, and they could be also established some additional teams. I know that there is expected some discussion between people from WiseUp and our team. So there will be organized as free possibility to discuss the future. Oh, I didn't mention the things related to the metadata. Probably Raul. There are some guys from our group who will deal. Yes. Raul, and about the, because languages were also mentioned, so I expect that Aaron, John, they will be from the side of the people whom I know. So, John, please.
Show yourself.
Aaron. So there are people who are related. Of course, if anybody will go with other ideas, there will be tables and you can sit and work.